Good morning, student. Are you
Good
there?
morning, sir.
Good morning,
Yes,
dear.
yes.
Good morning,
Good
sir.
morning,
Good
sir.
morning, sir.
Let us start. Uh, Filters. We have already discussed last class linear filters. I will take 5 minutes to recall that. That is, we know that the filter is used to apply to a image or picture uh, to uh, to get a enhanced picture, best quality picture as output. And linear filter basically use a mask. The center of the mask is known as your hotspot. You see, this is a hotspot. And we have already discussed there are some steps. We have to keep the mask on that hotspot, and we use the product or filter elements with the corresponding element which is in neighborhood, the nearest pixel. And then we add up all the product and store it a correct position of the output image, and we get a new value for that pixel, and the new value is replaced by the old value. We had an example, you see, 4 is replaced by some value here, and 7 is replaced by, we had a discussion about this. Get a new value, you see, 4 is replaced by 5, 7 is replaced by 6. So uh, uh, we have to replace all the pixel of the element by uh, applying this formula. And the purpose of this smoothing is to diminish or to decrease the effect of the camera noise, spurious pixel values, and missing pixel values, if any. Uh, and you can tell it is an average filtering. We know that filter are different types. Under smoothing, we have average filter or mean filter. That is, the new pixel value is obtained by taking the average pixels value in neighborhood of x or I. You see here. Um, then median filter. In place of mean, uh, we took uh, median of that value. Similar, you see, these are the, we have discussed in the last class already. Please recall. 0 is in hotspot, and 0 is replaced by 3 by taking the median value. We have to sort the values, and as it is 9 value, the fifth one value is the median. So 0, you see, in place of 0 there is 3. So 3 is the median of these 9 data, and this is called the median filter. And median filter has some uh, advantages or disadvantages. You will get a question what is the median filter and write its merits and demerits. Similarly, this is also a median filter. We have to take more element in a 6 into 3. Uh, you see the matrix. We have to take a mask of 3 cross 3 or 5 cross 5. But this is the original matrix, and this is the pixel value of some values. That is 6 into 3, 18 values. 18 pixel is here. We have to repeat the process for all the pixels of that image. Then let us start the new one, maximum and minimum and maximum filter. So as this, we have discussed already, minimum filter, sorry, mean filter or average filter. That is the pixel which was in hotspot is replaced by its average value, mean value. It is called mean filter. It has some properties we have already discussed. And now just we have discussed median filter. That is in place of mean, we have to calculate the median values, and it has also some merit and demerits. But as the name suggests, minimum and maximum filter, you see, the max and min filter are defined as g of xy is minimum of x plus I and y plus z, where I plus z belongs to the window xxy. So where xxy denotes the filter region, the region to which you want to apply your filter. Usually it is a 3 cos 3 pixel. Mean filter removes salt noise, white dots with large gray label values, because we have to the minimum value. So minimum value means the maximum value must be replaced. If the maximum value maxi value is replaced, that is the replace of white color. You know that 0 to 55 is the gray label value. 255 is the maximum value. So if you take minimum of 2, so the brighter value is replaced. Okay, so that is why it is called a salt noise. You know that the color of salt is white. So that is why the name is salt noise. As a white dots with large gray label values. So name is salt because the salt color is white. Okay, so because any large gray value within a 3 cos 3 filter region is replaced by one of its surrounding pixel with smallest value. So the gray level value which is the smallest must be darkest. That is less brighter than the maximum value. You know that if two pixel value, suppose one is 100, another 220, 220 is more brighter than the pixel value which have been 100. So if we take suppose two pixel, one is 100, another 220. So the minimum is 100. So 220 is replaced by 100. That means a brighter pixel is replaced by a new darkest pixel. So that is why if there is any salt noise, that is if there are white dots, this should be removed. But as a side effect, mean filter introduced dark structure in the image, obviously. So it introduced dark structure because it is replaced by minimum value. So it introduces a dark structure. You will get a image which is darker because all the pixels replaced by the minimum value. So if so you see here, so that is why it is an side effect. It is you can, in other words, you can tell it is an demerit. So the reverse effect is expected from max filter. So as the name suggests, max filter, it is opposite to mean filter. It removes paper noise. So you know that the color of paper is black. So the black dot with small gray label values, because the black dot within 3 cross 3 filter region is replaced by one of the surrounding pixel with largest value. So largest value means it replaced by the brighter value, more whiter value. So white dot or bright structure are widened as a side effect, as black dot will disappear. So obviously black dot will disappear because in a region XY, this filter removes or black color, because it take the maximum value. Maximum value means more brighter. So if there any value is darker, it is replaced by its brightest value, its larger value. It is maximum value. So that is why it is called the paper noise. So you, most of the time you will get a question: what is short noise and what is paper noise? So you have to write the definition and don't forget to write its demerits. Let us see. In a single example, I have explained here two pixel, एक max filter and min filter. You see, this is a region of 9 fxy. So 0 is an hotspot. Please recall, in mean filter, we used to take the mean or average. In median filter, we used to take median of the data. But here we have take the minimum value of the this mask. In this mask is a 3 cross 3 mask. and 0 is the minimum. So that 0 is replaced by itself in a main function. So minimum is 0, so 0 is replaced by 0. If the hotspot is on 3, so 3 is replaced by 0. As the hotspot value is 0, minimum value is 0, there will be no change. That is, there should be a black spot or black dot, because the minimum function does not remove the black dot. Uh, you see, in other hand, uh, in a max filter, the 0 is replaced by 9. The 0 is replaced by 9. Okay, that is, the 9 is the largest value, and 9 is the brighter than 0. The pixel having gray level value 9 is brighter than 0. So 0 is replaced by 9, the max value. So here, that is the this is not the paper noise, and the first one is called your salt noise, which remove the white space. No white space is available in minimum in your minimum function, or sorry, minimum filter, and no black spot is there in your max filter. And the demerits of mean filter is, you see, minimum filter introduce dark structure. Similarly, the max filter introduce the bright structure. So these are two side effect, or you can tell it is a demerits of mean filter and max filter respectively. Okay, are you getting?
Yes, sir. Yes.
Hmm. So the concept is simple. That is, if you want to remove the black spot or a white spot, that is, you can use max function and mean function.
Sir, what type of questions will ask on the basis of
You
that?
will get, that is what is max function, mean function, or salt error. Most of the time I see that is, you will get a question, your salt error and paper error. Sorry, salt noise and paper noise. What are those, and what are its demerits?
So we have to solve the numericals.
You may give an example of this mean, what is mean function and max, what is mean and max filtering, but you have to write this thing. You have to this right thing. This is the max function, and this is replaced by the minimum value of the surrounding pixels. It's with smallest value, and max filter, and you have to write its demerits. That is, minimum filter introduces dark structure. Obviously, dark structure, which are minimum is darker. Minimum gray level is darker, and maximum filter is brighter. So obviously, it is introduced bright structure, the max filter.
Okay, sir.
Okay. Whatever written in the slide, you write those things. Don't write anything else. It is better. It is always a better practice to give an example. If you not ask, suppose that it is not asking the question. If you know that, so do not hesitate to write an example, or draw a image or picture or graphics, if possible. If not possible, you have to write. So this, you see, you may write your mean filter and max filter. If you question as a mean, what is mean filter, max filter, you write the definition, but don't try to give this example. Okay.
Okay, sir.
Uh, Histogram processing. So you know that histogram, it is a graphical structure which basically contains some rectangular graphs to represent a data. That is called a histogram, and it is used in image processing. That is, histogram of an image represent the number of times a particular gray label has occurred in an image. That is, you can tell it is frequency. how many times a particular gray level values occur in an image. Suppose take a small example. Suppose you have you have an image, and you know that that image contains um, uh, a lot of pixels, because a image consists of a lot of pictures. Sorry, a lot of image pixels, and each pixel has a different gray level value. Suppose there are 20 pixels containing a particular pixel value or gray level value 50. Okay, so there are some the 50 pixels having gray level value, suppose 100. 50 pixels. There are 50. There are a lot of pixels in an image. Suppose there are 50 pixels having the gray level value 100. Your histogram processing is used for that purposes. Okay, so it represents the number of times, how many times a particular gray label has occurred in an image. That is, a gray label 100, how many times it occurs. So it is a graph in which x-axis represent the gray label and y-axis represent the number of pixels for each gray label values. Okay, let us see. You can see there is an image. It contains some black color, white color, and other gray color with a different gray level value. Assume that each square is a pixel. Assume that each square is a pixel. Uh, mm, I think there are how many pixel? 4 into 3, 12. There are 12 pixel and having different value. The corresponding matrix is given, which represent the gray level value of pixel. There are 12 pixel, you see. And 6 is the maximum. Here 6 depend the white color. That for maximum, that is you can tell 255 represent maximum color or white color, but as it is 6 is maximum, so it represent white color. And you see 1, you see the 0 represent completely black color, and you see the pixel value gray level value 1 is darker than 2 is more darker than 3, and 4 is 3 is more darker than 4, and 4 is more darker than 6, and 6 represent the white color, that is more brighter. It not white color, but it is, you can treat that as a more brighter. So that is why it is represent a white color. Let us draw an histogram for the corresponding data. A table is generated with RK and NK. What is RK? Now, RK contains all possible gray level values 0, 1, 2, 3, 4, 5, and 6. And NK consists of the number of times the gray level value has occurred in this figure. So you see here, 0 has occurred 6 times. So you see in RK 0, 1, 2, 3, 4, 5, 6. We have taken the minimum of the 0, the maximum is 6. 0 is 6 times. 1 is once, so it is occurred 1. And 2 is twice, you see. 2 occurred twice. 3 occur once. 4 also occur once. There is no 5. So the number of time 5 occurs is 0. And 6 occur once, the last one. You see in the left hand side, Some portion is not visible, I think. So there is another x-axis, and x-axis is 0, 1 to 6, and y-axis is taken there. You see 0 is the tallest tower. If you take a rectangle, you see 0 is the tallest, and 0 has maximum value 6. 1 once, so you see the height of the histogram or that rectangle. 2 occur twice, so 2 is more taller, you see. 3, 4, and 5 has 0 value, and also 6. So 3, 4, 6, 2, 3, 4, 6 having the, sorry, 1, 3, 4, 6 having value 1. So their height are same. So what do you learn from the histogram? That is, you learn from the histogram that in that image, the pixel has maximum 0 values. That is maximum black color. So that is, if you want to process an image, you have a rough idea that how many gray level value is highest value. So by viewing this graph, I got an rough idea that my image contains more black color, more 0 values. It is more black color. It is obviously also true. You see that image, you will get more black color. The black color, because 0 occurred maximum number of times, 6 times, and 1 once, 2 twice. So accordingly, the histogram is drawn or constructed. So from the histogram, we will get an rough idea, that is about the you know, about the image, the gray level value, how many image, how many pixels contain a particular gray level values. So sometimes you will get a question of normalized histogram. You draw the histogram and also find the normalized histogram. Let us see what is normalized histogram. Normalized histogram is obtained by dividing the frequency of occurrence of each gray level RK by the total number of pixels in an image. You may take it is a probability. It is a probability. Please recall the concept of probability in mathematics. The probability is the chances of occurrence of an event, and it is the probability of an event is obtained by dividing, that is the number of a particular event occurred, the number divided by the total number of outcomes, the total number of possible outcomes. That is, if we draw a coin, the probability of getting a head is 1 by 2, because there is one head and number of possible outcomes are 2, head and tail. There is no third option. Similarly, if you roll a dice, you know, that is which is used in Ludo, your game, Ludo game, and if you roll that, the chances of getting, the probability of getting a 6 is 1 by 6, because there is a 6 happening once, and the number of possible outcomes is 6, 1, 2, 3, 4, 5, 6. So the probability of getting a 6 is 1 by 6. So here you will get, you see, the written as P of Rk, that is the probability value of Rk, is equal to Nk by N. N is the total number of pixel in that image. Okay. So where k is equal to 0 to L minus 1, because start with 0, you know, and where N is equal to total number of pixel in the image. Probability Rk, P of Rk gives the probability of occurrence of a gray level value. That is, if we find the probability of occurrence of all pixel and represent in a table. It is known as normalized histogram. You represent a table, then draw the histogram. The normalized histogram is different from the normal histogram. Obviously, you see there are different values. Uh, the sum of all component of a normalized histogram is equal to 1. This is, you know, that the sum of probability of all an event of a sample space is equal to 0. That is, sum of getting a getting a tail is 1/2, getting a head is also 1/2. You add 1/2, 1/2. There is no third event. Either you getting a head or a tail. When you uh, throw a coin, you will get two event. Either you get a tail or head. So getting a tail is 1/2, and the probability of getting a tail is head is 1/2. You add them, 1/2 plus 1/2 equal to 1. So the sum of occurrence of or probability of an event of a sample space of an experiment is equal to 1. Similarly, also here also the sum of all components of normalized histogram is equal to 1. You add them. If you will not get the sum 1, so that is you assume that there is some error in your calculation. So it must be equal to 1. Let us see an example. Find normalized histogram of the image. Same image we have discussed in the previous image. You see 0, 0, 0, 1, 2, 3, 2, 4, 6. The same one is, and this is similar to example 1. A table made with NK and RK and PRK is a normalized histogram is shown below. You see the total value is 12. There is a 12 pixels, so N is 12 here. P of RK equal to NK by N. N is 12. So total number of pixels is 12. And the RK value is 1, 1, 2. Sorry, it is 0. It is, I think it is mistakenly written 1. The first value of RK is not, it is 0. Yes, it is 0. So mistakenly it is written 1. So 0 is 6 times. So 1 is 1, 2 is 2 twice, 3 is once, 4 is once. There is no 5, so 0, and 6 occur once. So probability of RK is equal to 6 by 12 because total value is 6, and 0 occurs 6 times, so 6 by 12. And probability of the second one is 1 by 12, 2 by 12, then 1 by 12, then 1 by 12, 3 is 1 by 12, 4 is 1 by 12, 5 is 0, and 6 is 1 by 12. If you add all the component of a normalized histogram PRK, if you add all the values of PRK, you definitely you will get 1. That is 6 by 12 plus 1 by 12 plus 2 by 12 plus 1 by 12 plus 1 by 12 and plus 1 by 12. That is 6 plus 1, 7, 7 to 9, 10, 11, 12. 12 by 12, you will get 1. Okay. So this is your normalized histogram value. This is a PRK value. In previous case, we have to only normalize, so there is no PRK. But when the question is asked to find the normalized histogram, you need to calculate probability of RK. So this is the probability of RK value, and you see this is a normalized histogram. 0, 1, 2, 3, 4, 5, 6. In x-axis, I have take the gray level value of the pixel, and y-axis PRK value. In y-axis, we have take the PRK value, probability value, and you know that the probability of 0 is highest, 1 by 2. One is 1 by 12, 2 is uh, greater than the previous one, 1 by 6. So 1 by 6 is greater than 1 by 12. So you see it is more taller. 3 is 1 by 12. 4 is also 1 by 2. Sorry, 1 by 12. Mistakenly it is 1 by 2, it is 1 by 12. And 6 also 1 by 12. That is 1, 3, 4, 6, all are 1 by 12. Only first value 0 has 1 by 2. That is 0 occurs 6 times. Out of 12 is 6. So 6 by 12. It contains half of the image. So 6. So 0 is taller, you see. The probability of 0, the histogram shows it is taller. And that means 0 occurs many times. So you will get the same image as a histogram or normalized histogram. But here it represents the probability value only in y-axis. This is the difference between a simple histogram or normalized histogram. Let us see what type of information we will get from the histogram. So histogram, no doubt, it gives an idea about how many times a particular gray level value of an image occurred. You will get that idea. That is in previous example, we get that 0 occurs maximum number of times because the 0, the probability of 0 on the histogram of 0 is taller, it is like a tower. It is tallest than all the, you see 0 is tallest, and so that is you will get an idea that 0 occurred maximum number of times. So based upon the histogram, we can categorize the image in the 4 categories which are defined below. Underexposed image, uh, and um, figure, there is a figure shows an underexposed image and its histogram shown in figure B. It may be noted that almost all the pixels are concentrated at the lower end of the histogram. The maximum value of gray is less than 50. No details are seen in the image because all are seen on below 50. And if you all the image, all the pixel value or gray level value is below 50, so you will get a darker image because 0 is, sorry, 50 is closer to 0. Let us see. You see. Underexposed image. You see the black color are there. That is, it is underexposed. And from histogram, you see all the graph are nearer to 0. That is one of the your left side. So from this histogram, that is, we had an idea that our image is underexposed because the histogram is left side of the graph, and it is beyond the value 50. You see, it is beyond the value 50. Here is 50, and all the value is left side of the 50. So all the value is less than 50, and you will get an if you see this histogram, so you will get an idea that that is all the value was less than 50, and it is a underexposed image. Let us see the second one, overexposed image. It shows an overexposed image. In that figure you will see the histogram is prominent towards the higher side of the gray level value with the lowest gray level value around 150. So you will get all the gray value which is greater than 150. The lowest value is 150. So if it is greater than 150, so that is it is closer to 255. If it's all the image having the value closer to 255, so it is more brighter. It is more brighter. So it is known as overexposed. So this image has a washout look because of the absence of darker sadness or gray. So it is more brighter, so than expected or than needed. So the picture is not clear. That is from the histogram. All the graph we will get. That is, it is the right side of the graph. You see the second one, overexposed image. Uh, you see the picture, the second picture, A, B, C. You see C and D. You see the C and the corresponding histogram in D. And you will find that all the gray label values and all the line or all the histogram bar are right side of the 150 or right side of the graph. So it is closer to 255 and your image is overexposed, more brighter. You will not get um, information from this image. It is not clear. So this is underexposed image, and second one is your overexposed image. Let us see the third one. Uh, in figure 4e shows a low constant image and its histogram is given in F. Corresponding histogram is given in F. The shape of the histogram is narrow and centered toward the middle of the grayscale. Middle means that is if the value is 0 to 255, the middle is around 127, 128. So all the gray value lies in the middle of the, you see here, that is it is a value, I think it is a start from 100 and it is a between 100 and 170 like that. And the histogram is you find a total middle of the graph. You see the first one is first, you see all the bar are left of the graph which is underexposed. In second one, all the graph you see, all the lines are right side in D, and F you see, it is exactly center. It is neither in left or nor in right side. So it is a, it is there in exactly center. So it is low constant. So you will get the line like this. So you will get an idea that it is in your low constant image. Then the last one, high constant image. So this shows an high constant image and its histogram is 4H. So the histogram cover a broad range of gray level, but distribution of pixel is not uniform. Distribution is not uniform, but it contains cover a broad range of gray levels. That is, it is neither in 0 to 50, nor in greater than 150 only, not only on the middle, but it the distribution of pixel, but it cover a wide range of gray level values. So, but distribution of pixel is not uniform. You see here, the number of some gray label are very high as compared to the number of other gray labels. You see here, the last one. So you will get, you see the histogram, and also check the quality of an image in the left side. The first one is underexposed, overexposed, low constant, and high constant. And from the histogram, the last histogram you see, your line cover wide range of value. That is, it start from near equal to 0, 10 or 20, and also ends near equal to 255, the highest value 250. So it covers widely range of the gray level value. The first one is only less than 50. The second one is all the above is 150. And the third one is in between 100 and 170, something like that. But the last one you see, it is between 0 to almost 250. So it cover wide range of pixel value. There is no uniform. It is distributed non-uniformly, and you will get a best quality image, high constant image. So out of the four image you see underexposed, overexposed, low constant image, and high constant image. So from the bar graph, so you will get an idea which type of image you have. So histogram gives us this idea from an image.
So, sir, overexposed means too much light.
Yes,
Underexposed
yes,
means little
less
light.
light. Hmm.
Okay.
Exactly. That is, you see, all the lines are below less than 50, so it is already underexposed. And if the more light is there, all are less than greater than 250, you will get more light. So it is overexposed. Okay. And if it is in the middle, that is it is so it is a low constant and high constant.
So, middle, what does that mean, sir? That
That means all the image are in the middle. Middle means that is you will get a particular color only. That is middle color. That is neither darker or nor brighter. That is you imagine that is a pixel having pixel value 128. 128. That is it is year 28, 127. They are same. So you see here that is all the it is greater than 100 and between 160 or 170. So no doubt it is better than your underexposed you see or overexposed, but it is still unclear.
right, the surroundings are totally unclear. Yeah.
Hmm. Okay, so the you will get some idea about the image you have. So the application is histogram indicate the clipping is a problem in the image. You know the clipping is a problem that is it is extensively used in threading. We have already discussed threading. Please recall threading, clipping. We have already discussed, and it tells us about image constant. So you will get the image constant either the low constant or high constant image. So this is the application of histogram. So then image enhancement and filtering in frequency domain. We have already discussed the same thing in spatial domain. Please recall that is in two domain. One is frequency domain, one is spatial domain. So uh, in the previous unit of this course, we have considered an image in the spatial domain, which is the form in which camera capture it. In this unit, we shall view the image as a signal and apply the well-known filtering techniques used as signal processing. So the frequency domain filter are categorized as smoothing filter, sharpening filters, and homomorphic filters. You see, there are some smoothing filter. It is called some idea, Butterworth, Gaussian filters, sharpening filter idea, Butterworth, Gaussian, Lapsian, and that's sharpening filters and homomorphic filters. नहीं है हमें. smoothing filter or low pass filter, LPF, edges, sharp transition and noise in the gray level contribute to high frequency content in an image. A low pass filter only passes low frequency and block the high frequency. As the name suggests, it is a low passes filter and it is associated with the signal. This low pass filter only passes low frequency and block the high frequency. That is, you will not, after filter, you will not get any pixel having high frequency data. So it removes noise, but in the process introduce blurring as a side effect, as a demerit in the image. So a low smoothing filter, no doubt it is gives a, it removes noise, but you will get some blurring effect as a side effect, or as you can consider it is an demerits of smoothing filter. So the basic model of filtering GUV is HUV, which is a use FUV, and FUV the Fourier transform. We'll discuss about the Fourier transform. That is, it use one type of transformation, and HUV the transfer function of the filter. Any function you can tell, but if you will get FUV the original one, and HUV is the function applied to FUV. So after applying the transfer function, you will get GUV, enhanced image, where high frequency component have been altered. That is, you will get, that is a high level high frequency component are have been altered. That is, there is no, you will not get no pixel having high frequency. Ideal filter has a sharp slope in transition band, whereas Gaussian filter has smooth slope in transition. Butterworth filter has a parameter called filter order, which control the slope of transition band. So higher value of filter order leads to ideal filter. So uh, um, this is the function of different filters: ideals, Butterworth, and higher filters. Let us discuss ideal low pass filter. It is also a low pass filter, removes all frequency above a certain frequency component D0. That is, we know that the low pass filter only passes the low value signal and block the high level values. So how you consider which is low frequency and high frequency? That is, there is a particular component, particular value D0. If that frequency is less than D0, it passes. If the frequency is greater than D0, it blocks. So ideal low pass filter is defined by the transfer function HUV equal to 1 if DUV less than equal to D0. Okay, अगर D0 से कम है तो consider it is a low pass, it is a low value, so it will passes it. But if DUV greater than D0, it assumes that it is a higher value frequency. So as it is a low pass filter, it blocks the high frequencies. So it is zero. It blocks it. It doesn't pass it. So it is zero. Okay. And this mathematical function is used. DUV is equal to U minus M by 2 plus V minus N by 2 half. You can take the root over it. DUV, the distance from the UV, and the center is M by 2 N by 2. If the size of an image is M cross N, then the center is at M by 2 N by 2, and filter transfer function is the symmetric about the midpoint. That is, symmetric means that is, if you divide that in midpoint, you will get two identical paths. D0 is non-negative quantity, because it is non-negative quantity. That is, if it is a particular value D0, so if the signal is less than D0, so it passes it, otherwise it is block it. So D0 is a non-negative quantity. Specify the frequency content to be retained. It is called cutoff frequency. Figure 6b is a plot for ILPF, and figure 6c written. is a picture is a perspective plot and C is a filter displayed of an image. So function transfer and if ideal paper only 0 and 1 you see. Some values lies between 0 and it is maximum value is 1. As it an ideal filter, it is non-real, non-actual and non-physical, but it can be stimulated in computers. 8B to 8C show low pass filter image with different cutoff frequency. As the filter reduces increases less and less power and information is removed, which resulted in less blurring. So it is a less and less power of and information is removed. A very noticeable effect that can be seen in the output image is ringing. Ringing, what is ringing? Ringing is undesirable and unpleasant lines around the object present in the image. Sometimes you will get this noise, ringing noise. That is in it is unwanted lines. Some undesirable and unpleasant lines sometimes happen or sometimes available around the object, and this is known as ringing. So it is used to remove that increases. As the cutoff frequency D0 increases, effect of ringing reduces. So ringing is a side effect of ideal IPF, uh, ideal LFF, lower pass filter. So if the D0 increases, so the effect of ringing decreases. And you see, this is original image. And output of ILFA with D030, that is all the signal less than 30 will be passed only. And output of ILF with D0 equal to 50, you will get the D050 is more clearer than D030. In D030, there are, you see, it may visible to you, that is, there are some unwanted line. And if we increase the D0 value, that line disappears and we will get a more pictures, clear picture. You see the second one, some text was written there, some text are written, the original image you see. And if you take ILF value which D050 in the second one, that is B, we are not able to read it. So there are some ringing effect. But if we increase the D0 value 80, so it is more clear than the first one. So a perfect D0 value must be selected. So this is about ILPF. Okay, so the slide of this file is over. So let us start another new topic. The next and important topic is geometric transformation. That is geometric transformation means we can transform an image to others. That is one place to other place. We can change the size or shape, and now it is applied a 2D image, so it is known as 2D geometric transformations. Let us see. So there are basic 2D transformation, a translation, rotating, and scaling. These are the basic and homogeneous representation of coordinates. We'll discuss in the objective. The objective of this transformation is we will have an idea what is translation, what is rotation, and what is scaling, and what is homogeneous representation of coordinate. We know that there are two coordinate, x and a y coordinate, Cartesian coordinate. But we will have an idea about homogeneous representation. What is homogeneous coordinate? Besides that, 2D composite transformation, translation, rotation, and scaling are single composition. Single transformation. Single transformation. It can be used once at a time, and it is called single transformation. We can combine both of them. That is translation, rotation, or fast rotation then translation, or the translation, rotation, after that is scaling. So if we apply more than one transformation method, translation, rotation, or scaling, in a single to a single image, it is called 2D composite transformation. And other transformation besides these three is reflection and shearing. So almost we have 5 type of 2D transformation: translation, rotation, another one is scaling, and the other two is reflection and shearing. So in this chapter, we will discuss about 5 transformation, and after that we will the reflection and shearing. As we discuss, what are the need of transformation? What is the need of geometric transformation? Uh, in some book it is written that it is a modeling transformations. Geometric transformation, sometimes some books it is referred as modeling transformation. You will get some uh, in books, some book you will get in place of geometric transformation, it is written as modeling transformation. Geometric transformation. The need of the geometric transformation is we have changed an object position. Suppose you need to change the position of an image or a object, you will be able to do it. You can rotate it. Sometimes we rotate our image in anti-clockwise. Uh, this is known as rotation. And the first one is the translation. Translation means you want to change the object location, object position. Suppose the object is at one position x, y, and you want to change it another position x dash, y dash. We are able to do it using translation. Similarly, if you change the orientation or if you rotate an image, it is known as rotation. And if you want to change the size, that is, if you want to increase the size of an object or you reduce the size of the object, you have to use scaling. So it is clear that the translation used to change the position, the rotation used to change the orientation, and the scaling used to change the size of an object. And other transformation is reflection. That is, you can reflect an object. You will see your image when you are standing in front of a mirror. That is known as your reflection image. You will get when you stand in front of a mirror. So this is the reflection image. And shearing also another important transformation which is used to change the shape, not size. There are two difference between and size and shape. That is, shape means that is you can shape, you can change the a rectangle to a square having the same area. The area of a rectangle is equal to the area of a square, but you want to change the a rectangle to a square. It is known as changing in shape. Changing in shape. And size means there is a rectangle, you want to only increase its size. Okay, so after applying the scaling, you will get the same object, but in either larger side or smaller side. But shearing means you want to change the shape. A rectangle may take the new shape as a square. A square may take the new shape as a rectangle. So you find the difference between a scaling and a shearing. Okay, so you got an idea what is are the four transformation, what is translation, what is rotation, what is scaling, reflection, and shearing. We will discuss details, but this is the basic idea about these five type of transformation: translation, rotation, scaling, reflection, and shearing. Translation for a position, rotation is orientation, scaling is a size, and reflection is you will get an reflection image when standing in front of a mirror, and shearing is used to change the shape. Let us discuss one by one. Basic 2D geometric transformation, and the first and important transformation is translation. You see, uh, this is a line uh, P dash. Suppose you seek a point at P. Let first take the example of a point. The point is initially it was at P. You see, it is initially it was P. My aim is to change the location to P dash. Due to any reason, I want to change the location of that pixel or that point. The point initially it is now in P. I want to change it to P dash. So as it is the change the location. So concept of change the location, we have to apply here translation. So translation is used to change the location of an object to another. So here I want to change the location of that point from P to P dash. So and let xy is the position of the P, and x dash and y dash is the position of P dash. That is, I want to change the location of P xy to x dash y dash. In order to achieve that, I have to apply or add tx and ty translation factor to x and y to get x dash and y dash. You see here, x dash is equal to x plus tx. So the new position along x axis is calculated as x plus tx. That is, I have to add some tx, which become the new x coordinate axis. Sorry, new x coordinate point. Similarly, ty is added to y to get a new value of y dash. And this is the matrix now. That is P equal to xy, P dash is equal to x dash y, that is we get. and T equal to Tx Ty. And all are, you see, there are column matrix. First is a column matrix, second is also a column matrix, third is a column matrix, one column and two rows. And finally, you can write P dash equal to P plus T. So you will get P dash if we add the P plus T. So you see, if we add P plus T, you will get P dash equal to X plus Tx and Y dash equal to Y plus Ty. That means I have added Tx and Ty to the original position to get a new position of P. That is P dash. This is a simple translation. I have not changed the size here. Okay, I have not changed the shape here. I have not rotated. Only simply transfer from one location to another location. So that is the work of, that is the function of translation. If you want to change the location only, use translation. You are in factor Tx Ty to X dash Y dash. So your translation move the object without deformation. There are no change in other. So that is called rigid body transformation. So only change the location. Whatever the size, shape, and orientation of the object, it remains same as it remains unchanged. Only location is changed.
Sir, what is the meaning of this T over here?
Deformation. I am not getting.
Hello?
What is the meaning of
T.
T?
T for Tamil Nadu, T.
T, that is in picture T. It is after translation. It is translation. T stands for your translation. That is P is translated to P dash.
Translation or transformation, both are the same word in
No,
this
no,
context.
it is actually it is the transformation. Translation is one type of transformation. Translation is one type of transformation. Okay, so P is translated to P. That is P has changed its size. So T
So in
here
this
stands for
diagram,
translation.
it is just showing that P is transforming from P to P dash.
P to P dash. So actually translation means one type of transformation. Translation means one type of transformation. So you can tell P is also transformed to P dash.
Sir, when T
Okay.
is converting into P dash, so is there any character or any, the size or shape will change or
Not
it
change,
will
not change,
remain
not change.
same?
Only location change. Only location change. No other component changed. The size, shape, and orientation exactly remain unchanged.
Okay.
In previous slide, we are able to only translate only a single point only. But suppose we have a line segment. We have to change that line to another position. There is a line. We have to change that entire line to other position or other location. So it is simple. You know that a line is nothing but it is a combination of the points. Combination of points. So you use translation method to each and every point of the line. Suppose that line contains 20 lines, 20 points. So we have to use the translation point to every and each point. No, we need not to use the translation to every and each point. We have to only translate the starting point and end point. So once the starting point and end point are translated, to simply join it. You need not to translate all the points of that line. You see here, to move a line segment, apply the transformation equation to each of the line endpoints and redraw the line between new endpoints. Okay, only the initial point and final point. 2 points you need to translate it or transformation. Similarly, to move a polygon, suppose a hexagon. Hexagon, how many points in hexagon? N points? 6 points. 6 points. So apply the transformation equation to the coordinate of each vertex only and regenerate the polygon using the new set of vertex coordinate. You need not to use the transformation formula or translation formula to each and each point of the line. You have to only apply the transformation formula only to the vertex only. As example, if there is a hexagon, you need to change its position. You only translate these 6 points only. So this is your basic translation, where we used to change the position only, location only. You can able to change the position of a point. We are also able to change the position of a line. Also, we are able to position of a hexagon. Or polygon. Then basic 2D geometric, second one is rotation. You can rotate an object from one position to another position about some degree, you see, either in clockwise, either anti-clockwise. So there are two rotation axis and rotation angle. So we need two things. One is a rotation axis, another is rotation angle. Yes, another is rotation point. In which point you want to rotate, that is called the pivot point. You see here, one is rotation axis, that is you want to rotate the object either in x-axis or y-axis. Rotation angle, in which angle you want to rotate, either in 30 degree, 90 degree, 60 degree. And next
So
is
direction
rotation
of
point.
the, sir, direction of the rotation could be anything, na? I mean,
No,
clockwise or anti-clockwise.
anything. It might either in a positive or negative. Plus 30 means counter or anti-counter. It depends upon the sign of the theta. Okay, we'll discuss in next slide. We'll discuss about the direction. The next slide it is clear. It will be clear that is if theta the direction of an angle or rotation depend upon the sign of the theta. You see, if theta is positive, the rotation is anti-clockwise, counterclockwise. If theta is negative, the direction is clockwise. Because you know that in cos A plus B, there is a negative sign. So if it is a negative, it is clockwise, and if it is positive, it is anti-clockwise rotation. Here, at first, suppose the pivot point is at an origin. That is, you want to rotate with respect to origin, not in other point, with respect to origin. So x dash can be calculated here, r cos theta plus phi. So you know that r is equal to that is x square s square cos theta plus y cos theta of root over, and r cos theta plus alpha, that is r cos theta plus r cos alpha minus r sin theta. This is the formula of cos a plus b. Cos a into cos b minus cos a into cos sin b. So y dash equal to sin alpha cos a into sin a plus, here is plus sign, first one negative signs. So x equal to r cos phi and y is equal to r sin phi. First we have to convert this is x to r cos theta, and x dash equal to x cos theta minus y sin theta, and y dash equal to s sin theta plus y cos theta. We have to convert that xy to in form of r cos theta and r sin theta sin alpha, and that is your rotation matrix. That is P dash equal to R dot P. Please recall the translation. Translation is P dash equal to uh, x plus T. That is P plus T. You see, in previous year, this is written as, translation is, you see, P dash equal to P plus T. That is P plus T. That is translation matrix is added to P. You will get P dash. But to see, in place of your rotation, that is P dash equal to R dot P. So what is R? That is your R. Cos theta minus sin theta plus cos theta. If you multiply this thing, you will get the formula that is same formula and previous one.
Sir, what is it is written in this, the box? Cos theta minus sin theta and sin theta, and there is
Which
a
one? The
sign is
previous one.
missing. Sorry,
Cos theta minus sin theta, sin theta plus cos theta.
प्लस मिसिंग है ना यहाँ पे.
No, it is only matrix form. What is the? This is R. R means cos theta minus. If you multiply R and P, you will get P dash. If you multiply R dot P, that is, you will multiply two matrix, you get P dash. So S dash Y dash equal to your cos theta, that is sin theta cos theta into P. Okay, XY. If you multiply R and P, you will get P dash. Okay, you see, X dash equal to S cos theta minus Y sin theta. You write on copy that. That is your here cos theta sin theta minus sin theta cos theta. You multiply X Y. You will get X dash Y dash. That is X dash Y dash equal to cos theta minus sin theta cos theta R is R. Then dot XY, a column matrix XY. You multiply that, you will get X dash. Cos theta into X minus sin theta into Y. Isn't it? I think it is not there. Not there. Are you getting or not? That is P dash is S dash Y dash equal to this matrix cos theta minus sin theta cos theta into XY P. You multiply the R with P, you will get P dash.
Sir, have you calculated the value of this matrix, value of R? I mean, in the next slide it has been given.
No, value of R is called, if theta is given, you will get value of R here. R means, your R means here, that is your rotation matrix. A rotation matrix is,
So
it is not actual R.
angle we have to
You will
find out.
not get,
Angle.
no, you will not get a single value of R, because R itself is a matrix. Matrix does not have any value.
Okay.
Okay, so you will get this matrix, that is, you will cos theta minus sin theta cos theta. You multiply with x and y. You multiply with it p. P is x, y. X, niche y. That is x, y column matrix. And you will get a new formula. That is x dash equal to cos theta into x, x cos theta. And then minus sin theta into y. Then minus y sin theta. Which one in the previous example you see? X dash equal to x cos theta minus y sin theta. You see the last two lines. X dash equal to x cos theta minus y sin theta, and y dash equal to x sin theta plus y cos theta. That is your the new value of x dash y dash is calculated in this manner. You only multiply x with cos theta, then y to sin theta, subtract it, you will get x dash. And the new value of y is y dash, and is calculated as x into sin theta plus y into cos theta. And theta, what is theta? Now theta is the rotating angle. Suppose theta is 45. Cos theta is equal to 1 by root 2. And sin theta is also 1 by root 2. Okay, because sin 45 is 1 by root 2. Suppose theta is half. So, sorry, 30 degree. So sin theta is half. Okay. So, in this way, a new value is calculated for x and y, which will be x dash and y dash. Okay, so rotation of a point about any specified position is xr, yr, and the x dash is nothing but xr plus x minus xr cos theta and y minus y minus. So this is a rotation, not about the origin. Even other, that is the pivot point is other, that is xr and yr. In previous example, we have considering that the pivot point is origin. But if we consider the pivot point is not origin, it is a other point other than origin. So we use this point, this value. S dash is calculated xr plus the same formula, x minus xr cos theta minus y minus yr sin theta, and y dash equal to yr plus x minus xr sin theta plus y minus yr cos theta. The same formula is used, but here it is the formula where rotation is a point about any specified position, xr or yr. So rotation also moves object without deformation. That is, only the object is rotated, but any other component remain unchanged. It is only rotated, the other shape and size remain unchanged. Similarly, a line is rotated by applying the rotation formula to each of the endpoint and redrawing the line between the new endpoints. So in case of you have to rotate a line, you need not to rotate all the points one by one. You have to only rotate 2 points only, the end point and the initial point and the final point, the start point and the end point. And then after rotating only that 2 points using this formula, we have to redraw the line. You have to join the line. So you will get your desired output. Similarly, in place of a polygon is rotated by applying the rotation formula to each of the vertices and redrawing the polygon using new vertex coordinate. So in this is the same as in case of translation. In place of translation, we have to translate each point of a polygon and then rejoin it, redraw it. Similarly, here also you can rotate all the points, vertices only, vertices of a polygon, and then you rejoin it. You need not to apply rotation formula to each of the points. You have to only apply the formula of the polygon. In place of there is a pentagon which contains 5 vertices, you have to only apply the formula of rotation of those vertices only.
In
So
this
this is
formula,
your
R stands for rotation, is it?
yes. Which are?
XR, YR.
No, it is a specified position. About any specified position. Okay, suppose here in previous class we have to rotate in with respect to which origin?
Pivot.
With respect, but here we have to rotate about any other position, in other point other than origin.
So R is that other point.
X or Y R, not R. No R is there. Y R X R is it? X R means that is actually not X0 Y0. Basically X0 Y0 or X not Y not, it stands for origin. So X R Y R means any other point other than origin.
Okay. Thank you.
This is not required. This is 2D rotation routine. A small function is there using our C language. It is actually not in the course. It is in other student course. So I used to take the class of theirs. So it is not required. This you may ignore these slides. You need not to write an C program for the rotation routine. Okay, so you may ignore these slides. Okay, so 2D scaling, same thing. Okay. So today we discuss two transformation, important transformation. One is translation, another is scaling. Sorry, rotation. Okay, this is single transformation, but sometimes we need to apply the same thing one by one in a single object. That will be the composite. We'll discuss about that. The composite transformation. Suppose we need simultaneously translation and rotation, one by one, not simultaneously, one by one. So first you apply the translation and then rotate it. That is, at a time you want to change the position as well as rotate it. Okay, so that transformation is known as the composite transformation, which we'll discuss in next class. We'll discuss about that. So today only we have only discussed the rotation and the translation. The next class we will start from the scaling. Okay, please write your name and number, registration number, I think, enrollment number, whatever maybe, in a board, so that we give the attendance. Please wait, I will take a snapshot of your class. 1 minute. Okay, thank you students for joining.
Thank you. Thank you, sir.
Yes, you
Thank
can
you,
leave
sir.
now.
Sir.
Okay,
Remember
you
to
can leave
share
now.
that
Meet you in the next class.
231 PPT.
Okay, obviously I will send today.
Thank you, sir.